Good morning, dear student. In today's lecture, we are very much interested in the disaccharides. So, what is this disaccharides? The disaccharides are the compounds of two monosaccharides unit joined by glycosidic linkage. So, in previous lecture, we already discussed the glycosidic bond between two monosaccharides. So, this disaccharide is nothing but these are the compound of two monosaccharides units joined together by glycosidic linkage. And the most familiar to us, that is maltose, second is lactose, and third one is sucrose. So this maltose, it is a combination of glucose plus glucose. Okay, so in this case there is alpha 1,4 linkage. Okay, anomeric carbon, it is interact with the carbon number 4 of second glucose molecule. In lactose there is another glucose molecule, one is glucose is there, another is galactose molecule is there. Again, if you consider, this is your alpha anomeric carbon of glucose first. Okay, and the beta, okay, carbon number 4 of this beta galactose, it will forms the lactose. And third one is your sucrose. So sucrose, that is glucose plus fructose. So in this case the linkage is 1,2 linkage, it is not 1,4 linkage. So you should keep in mind that is maltose, it is a combination of glucose plus glucose, with the help of glycosidic linkage. It will forms the disaccharide maltose. Okay, alpha 1,4 linkage means both the glucose are alpha D glucose. In this lactose, the glucose molecule is your alpha and the galactose is your beta. The galactose is your beta. Then the sucrose one, the third one, that is sucrose, it is glucose plus fructose, and in this case there is a 1,2 linkage. So you should keep in mind. So in this case, maltose and lactose, there is 1,4 linkage, while in sucrose there is a 1,2 linkage. So let us discuss the first one, that is maltose. Okay, let us discuss the first one, that is maltose. So maltose, if you see some properties of this maltose, so the first one, that is it is not occur in the body, not occur in body. Okay, second, if you see this, what are the sources of this maltose where it often, okay, okay, so what are the sources of this maltose? That is the cereals. Okay, germinating cereals, germinating cereals. Okay, third point, that is it is hydrolyze. So it undergo hydrolysis reaction. So it hydrolyze to gives two molecules of glucose, two molecules of glucose. So it hydrolyze to gives two molecules of glucose. Okay, again, if you see the next important point regarding to this maltose, that is it is not occur in the body, its sources is germinating cereals. Upon hydrolysis it gives two molecules of glucose, the glycosidic bond get cleave and we get two molecules of glucose. uh, if you see this maltose molecule, it has free aldehyde group, it has free aldehyde group. Okay, it has free aldehyde group, and therefore it will shows muta rotation, it will shows muta rotation. So we are very much familiar with this muta rotation. So we know that the hemiacetal form, it is convert into open chain form, and the open chain form again convert into hemiacetal form. So in this case, no doubt there is a both this glucose molecule in hemiacetal form, and there is 1,4 linkage. Okay, anomeric carbon of first glucose and the fourth carbon of second glucose, but it undergo the cleavage. Okay, and there is a formation of free aldehyde group, and therefore this maltose, it will shows meta rotation. It will shows meta rotation, and it can be exist due to this meta rotation. It can be exist into two form, that is alpha or beta form. So it can be exist in alpha or beta forms. So it shows meta rotation, and due to this uh, uh, it will observe in two forms, that is one is alpha. It is exist in two form, that is one is alpha and second is beta. Again, if you see this, due to this free aldehyde group, it is act as a reducing sugar. It is act as a reducing agent or reducing sugar. So it will gives positive test with your tolerance reagent or Benedict solution. So at least you should know this all these points. See this maltose, it is a combination of glucose plus glucose. Its sources is germinating cereals. Upon hydrolysis, it gives two molecules of glucose. It has a free aldehyde group, and therefore it shows beta rotation. It will exist in two forms, that is alpha or beta forms, and it will reduces the tolerance reagent. Therefore, it is act as a reducing agent. So we see the structure of this maltose. Okay, so we are very much familiar with this structure. So this is your, okay, HOH, the remaining group is there, and here HCS2OH group is there. Okay, so this is your alpha D glucose. Alpha D glucose. So this is your carbon number 1, and this is your anomeric carbon. So it will interact with another molecules of this alpha D glucose. Okay, so this is your OH, and the remaining group is there. Okay, HCS2OH is there. Okay, so in this case, this water molecule will lost here, and there is the formation of glycosidic bond between these two glucose molecule. So what you get finally, so we get this, and this oxygen. Okay, so HOH, and the remaining group is as it is H, and CH2OH is there. Okay, HCH2OH. So we already discussed which group is above the plane and which group is below the plane. So remaining group is as it is. Okay, so you just understand that is alpha D glucose, the anomeric carbon react with carbon number 4. So this is your carbon number 4. Okay, and there is a alpha 1,4 linkage. Alpha 1,4 linkage in this maltose. Okay, alpha 1,4 linkage in this maltose. Anytime the question is asked in this MCQ type. So uh, which isomer of this D glucose involved in the maltose formation, that is alpha D glucose plus alpha D glucose, and there is a linkage, and the linkage is 1,4 linkage. So let us discuss the second one, that is your lactose. So second, that is your lactose. So lactose is there. Okay, and we know that. So in this case, if you see the structure, so we only discuss the carbon first. So this is your beta D galactose, OH and H. Okay, H and CH2OH. So both the group on same side, that is the hydroxyl group and the alcoholic group is same side. Therefore, it is beta D galactose. Beta D galactose, because both glucose and galactose are epimers at carbon number 4. We already discussed it, and the remaining structure you show just like this. Okay, so we are not very much interested in the remaining structure. So beta D galactose, it is react with again with your alpha D glucose. This is your HOH, H CH2OH. Okay, and there should be, okay. So this is your alpha OH, and H remaining is as it is. So this is your beta. So this is your alpha isomer. Okay, alpha D glucose. Again, there is a 1,4 linkage. So this water molecule will be leaves out, and there is a formation of 1,4 linkage. Okay. So this oxygen, HOH, HCH2OH, remaining as it is. Okay, so we are not very much interested in the remaining group. Okay, so this is your 1,4 linkage. Again, there is a 1,4 linkage between beta D galactose and the alpha D glucose. 1,4 linkage is there, 1,4 linkage is there, and it having the same properties such as maltose, that is, uh, it is act as a reducing agent. So it is also having free aldehyde groups, so it is act as a reducing agent. So this hemiacetal group undergo a reaction with your, we can say that undergo hydrolysis reaction, okay, or reaction with acid, okay, and this bond get a break between this oxygen and this carbon, anomeric carbon, and it is converted into free aldehyde group. Therefore it is act as a reducing agent, and it will shows positive test with your tolerance reagent as well as Bendix solution. Second, due to this free aldehyde group, it is also shows mutarotation. It also shows mutarotation. It also shows mutarotation. Again, the third one, upon hydrolysis, it will gives glucose plus galactose. Upon hydrolysis, it will gives glucose plus galactose. Okay, and again, the one more important point, that is, both maltose and lactose, it will forms ozazone. Okay, so the reaction with phenylhydrazine. So we are very much familiar with this ozazone. Both this maltose and glucose, it will forms ozazone with phenylhydrazine, with phenylhydrazine. It will forms ozazone with phenylhydrazine. So these are the some important properties of this lactose. So let us discuss the third one, that is your sucrose. Okay, sucrose, it is a combination of glucose and beta D glucose and beta D fructose. So this is your sucrose. Sucrose, it is a combination of this beta D glucose and beta D fructose. Beta D fructose. So in this case, so you should keep in mind, in this case the linkage is 1 to linkage. The linkage is 1 to linkage. Linkage is 1 to linkage. Okay, so we know that. Okay, so first we know that this is your fructose. Fructose is your ketose. Okay, C double bond O. Then we know that. Okay, the remaining is H. OH is there. OH, H is there. H, OH is there. H, OH is there, and finally this is your CH2 OH is there. So if you count this carbon, that is 1 2 3 4 5. I will make mistake, I will take one more. So I will try first. Okay, so this is your CH2 OH, this is your carbon number second. Okay, C double bond. Then there is a carbon number third, H, OH. Okay, so then there is a this carbon, that is here H, OH. So I will draw it like this. So, okay, so this is your CH2OH, C double bond O. Okay, this is your carbon then there should be HOH is there, HOH is there. So one, two, three, four, and this is your five, and finally this is your six carbon is there. So only the difference is that here we can write this is your OH and this is your H. Okay, so we get this. So this is your fructose. So it is in Fischer form. Okay. So first you have to convert this Fischer into its Haworth projection formula. Okay, and we know that it is more stable in five-membered ring as compared to the six-membered ring. So okay, so in this case again, this carbon number five, six, this hydroxyl group of carbon number five, it will interact with this ketonic group, and there is a formation of, okay, five-membered ring. Okay, so what you get finally, so we get this, that is this oxygen is there. Okay, oxygen, it will binds, so we can draw like this. Okay, five-membered ring we draw first. Okay, in this case, this is your, so this is your beta. Okay, this is your beta, means this CH2OH is like this is your carbon first, and this is your OH group is there. Okay, this is your carbon second, third, fourth, fifth. Okay, and the sixth one,